Hi class, this is Dr. Karsten, and today we are doing lesson 19 from Module 5, Grade 4, EngageNY Math. And in today's lesson, we are doing word problems involving fractions. So at this point, you are all pros at working with fractions. You know how to add them and subtract them, compare them, how to work with related fractions or those that are not related. So let's see how well we can do with today's lesson. So I'm going to jump right into the problem set, but I do want to point one thing out to you before we get started, and that is that here it says use the RDW process. So I think at this point you guys have probably been using this process for many years, but remember, you read the problem and then you think, can I draw something to model this? And that's going to be really important to this before we go and we try and work out the solutions. So I really want you to focus on that D portion of the process. I do want you to draw something for each one of these before you solve them, and it might be as simple as just drawing a tape diagram that shows the parts and the wholes that you can figure out what you're looking for. And before we do that, let me just really quickly remind you of what that might look like. So for example, if I drew a tape diagram that had two parts to it, then it would be part, whole. So I'm going to go ahead and fill in some numbers here. Let's just say that this was 3 and this was 4. Then you would know that the whole thing is 7. And what you know about this is similar to fact families, which we were doing a lot of last week. What you would know is that if my whole was missing, I know I can just add my parts. Or if one of these parts is missing, then I know that I can subtract the other part that I have from the whole. So for example, let's say this was missing, then I know I could take my whole and subtract the other part and get 4. So I just wanted to remind you of this, and this might be the simplest form of a diagram for you to be drawing today, but also let me say this, how I do this is the way that I'm going to do it. You could actually solve these in a different way, and that's fine. There's more than one way to solve each of these problems, so you should do what works best for you. I'm going to work in a variety of different ways today, but you should choose the way that works best for you, and that's fine. I'll take a look at your work and I can see how you solved them. As long as you're getting the correct answer and you're doing a correct way, we're good. So let's take a look at the first problem. Sue ran 9/10 mile on Monday and 7/10 mile on Tuesday. How many miles did Sue run in the 2 days? So here I have what she ran on Monday, here's what she ran on Tuesday, and I want to find what she did on both days. So I definitely realize that I'm going to be combining these. I'm going to go ahead and make myself a tape diagram to help me here. And in this one again, for this one, I'm going to have my two parts, and then we are looking for the whole. So here's day 1, Monday. Monday, she went 9/10 of a mile. Tuesday, she went 7/10 of a mile, and I'm looking for the total or the whole thing. So how am I going to solve this? Well, clearly I'm going to add. I have the two pieces, I have the two parts, and I want to find the whole thing. So we're going to do 9/10 plus 7/10. Remember, the denominator is just telling us how large our pieces are. It's like a label, so I have 9 of these pieces plus 7 of these pieces, which gives me 16 pieces, and the size of the pieces is 10. But we do not want to leave this as a fraction greater than 1. We definitely want to go ahead and turn this into a mixed number. So since I'm dealing with tenths, I'm going to write that in my denominator. And what I want to do is I want to pull out one whole. Well, for tenths, what I know is that one whole is going to be 10/10. When my numerator and denominator match, it means that it's equal to 1. That's because it's cut up into 10 pieces, and I have all 10 pieces. So I'm going to do the same thing down here. So here I want to pull out one whole, which would be 10/10. And then if I had 16 here and I put 10 over here, that means that I have 6 of those pieces over here, and the pieces are all tenths. So now I can turn this 10/10 just into 1. And this is going to stay 6/10 because 10/10 is equal to 1. And now I have my answer, and I can go ahead and write that. And you know, I'm going to go and put mile there, and now I can write it. Sue ran 1 6/10 miles. Oop, I'm going a little off. Let me move it over. ran 1 6/10 miles in the 2 days. All right, first problem done. Let's move on to number 2. So let's take a look at number 2 and see what kind of a problem we have here. It says, Mr. Salazar cut his son's birthday cake into 8 equal pieces. Mr. Salazar, Miss Salazar, and the birthday boy each ate 1 piece of cake. What fraction of the cake was left? So I'm looking for what is left. I'm looking for a part of something. Now for this one, I think drawing a diagram and showing those 8 equal pieces might be the easiest way to go. So let's start there, and let's go ahead and draw ourselves a diagram. So I'm going to go ahead and draw this, and I'm going to want to put 8 pieces in there. So I'm going to cut this up into 8 pieces. I'm almost done. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So that represents the entire cake. And I'm going to go ahead and model and show that that represents the whole cake by bracketing that whole thing off and putting the number 1 above. So now let's think about what they ate. Each one of them ate 1 piece. So, Mr. Salazar ate this one, his wife ate that one, and the birthday boy ate that piece. So this is what they ate, and I can show that with words. And then the rest is going to be what's left. Now, I just want to kind of really quickly also model for you that you could have drawn it, if you saw it, again, like this. And you could have said, well, I have 3/8 here. I know this whole thing is equal to 1. So what do I have left over here? And that would have been fine. Either way is fine. Again, there's more than one way to do this. I like doing it this way since they're talking about 3 different fractions being kind of put together here. I think it's better to draw it in all the little pieces. So one thing that you might want to do is first to show what was eaten, you might want to go ahead and say that you have 1/8 plus 1/8 plus 1/8, and that's equal to 3/8. And that would represent what was eaten. Now, in order to show what was left, I'm going to go ahead and first write it like this and say I have a whole cake, and I'm going to eat this, and eating it means I'm subtracting. When you have the word left, that's kind of a hint that you're probably going to be subtracting. So minus 3/8. But now, this is hard to work with. Remember, whenever we have an unlike, right now we have unlike denominators, unlike units, what we want to do is we want to turn this into 8ths to work with. And I know that 1 can be written as 8/8. So I'd have 8/8 minus 3/8. So I have 8 of those pieces minus 3 of those pieces, which leaves me 5 pieces. And the size of the pieces is 8ths. And so now we can go ahead and write it. That 5/8 of the cake is left. Sorry, my handwriting wasn't the best there. That E is kind of out on its own. There we go. Okay, so again, for this one, for me, it was easier to draw it like this. You could have drawn it like this. I also feel like it's important to show how we got the 3/8, that we actually had a step here that we worked with. We showed that we were subtracting 3/8 from the 1, and that another way of writing the 1 is 8/8. So we had 8/8 minus 3/8. Since the denominator or the units are the same, we were able just to say 8 minus 3 is 5, and we kept the size of the pieces the same. So 5/8 of the cake is left. All right, let's take a look at the next question. So this one says, ooh, it's a little blurry. Let me bring it down a little for us. Maria spent 4/7 of her money. So she spent means I'm getting rid of. That means I'm losing it. That means I'm subtracting it. She spent 4/7 of her money on a book and saved the rest. What fraction of the money did Maria save? So we want to figure out what she saved. She spent this, she saved the other part. So let's go ahead and, sorry about all the noise, let's model that here with a diagram. So first I'm going to show the part that she spent. So this is what she spent, 4/7. And then I'm going to model what she saved. And right here I'm going to bracket off what she saved. And then I know that this entire thing is all her money. Well, all her money, when you're talking about the whole thing can always be represented as 1 when we're just talking about having one whole thing. So if they're talking about all her money and they're talking about 4/7 of it, that means 1 would represent all of her money. Now we are going to have problems where you have more than 1, but that's different. When they don't give you an amount for the whole thing and they just say all of it or the whole, it's going to be 1. So I have my 1 up here, I have my things here. Now for some of you, it may have been easier to go ahead and draw it like this, where you take a tape diagram and you turn it into 7ths. 1, 2, 3, 4, 5, 6, 7. You can show that this is 1. Then you can show what she spent. And then you can show what she saved. And that might be easier for you. You're still going to have to model it over here with a math equation with a number sentence, but it's fine to draw it either way, whichever way you see it better. So now if I wanted to model this, again, I'm looking for a part, and when we're looking for a part, we're subtracting, just like we did in the problem above. Up here, when we were looking for what was left, we were looking for a part, we subtracted. So we're going to do that again down here. So what I want to model is I want to first show, oops, sorry about that I have one whole, I have all of her money, and then we want to show that she spent 4/7. So it's gone. So she's subtracting it out of her total. Now, since I don't have a common unit here, I want to rename this whole as 7ths. And I'm going to have 7/7 because my numerator and denominator have to match to equal 1. So I have 7/7 minus 4/7. So since my pieces are the same size, I can just say I have 7 of those pieces minus 4 of those pieces. And when I have 7 pieces minus 4 pieces, that leaves me with 3 pieces. And again, you also saw that in our diagram down there. And now I have to write a nice little sentence to go along with it. So we can say Maria saved 3/7 of her money. Okay, I'm actually going to continue with the problem set because the problems get a little trickier and you are going to be working in the homework set today. So let's continue on into the next problem. And here we go. Number 4. And again, we're still in the problem set. There we go. Mrs. Jones had 1 4/8 pieces. Pizzas, not pieces, pizzas. So again, Mrs. Jones had 1 4/8 pizzas left after a party. After giving some to Gary, she had 7/8 pizza left. What fraction of pizza did she give Gary? So now, just because you tend to probably think of pizzas as being round, unless you like other kinds of pizzas, don't feel obligated to make round pizzas for diagramming. It's much better to not. But first I'm going to go ahead and do one of these part wholes. So let's do that first. So let's go ahead and draw this. Now, she had 1, this is what she had left. So make sure you're paying attention after a party. After giving some to Gary, she had that left. So what did she start out with for the purposes of this? We're not going to start with 2 whole pizzas because we're really starting the story after the party. So we're starting with 1 4/8. That's what we're dealing with. That's really our starting point for this. So don't start with 2 pizzas, start with 1 4/8. So basically 1 1/2 pizzas. Then she gave some to Gary. We don't know what she gave to Gary. What we do know is that she had 7/8 of that pizza left at the end. So I'm going to put a question mark here. So sorry about that. So I had a little distraction over here. So again, she has 1 4/8 pizzas left. After she gives some to Gary, so this is the part that she's going to give to Gary, and we don't know what that is. But this is what she has left for herself. So again, when we can diagram something as being part whole, and we're missing a part, we know that we're doing subtraction. We're going to take the whole, and we're going to subtract out one part, and then we'll have the other part. So let's go ahead and model that. So for this one, we're starting with 1 and 4/8. So that's what she had originally after the party. And then she gave some to Gary, but she ended up with 7/8 in the end. So for this one, we're going to subtract out what she had left, which I know sounds weird. Usually you're looking for what's left, but in this case we know what she had left. We're trying to figure out what she gave away. So again, it doesn't matter which one we subtract, we can always find the other one. So I have 1 and 4/8 minus 7/8, but I can't take that 7/8 away from the 4/8, so what I'm going to have to do is convert or rename this mixed number into a fraction greater than 1. So what I know is that 1 whole, if I want to turn it into eighths, is going to be 8/8. So I'm going to have that 8/8, plus I still have this 4/8. And if I combine those two, I'm going to have 8 plus 4 is 12/8. So all we did was we turned the 1 whole into 8/8. We held on to our 4/8 and we put them all together. I'm going to model that in a second in another way. And then I'm going to still have to subtract that 7/8. It didn't go anywhere. But now it's nice and easy because I can just say 12 of those size pieces minus 7 of those pieces. And that's going to leave me 5 of those size pieces. So I'm going to have 5/8. And then I can go ahead and I can write that Mrs. Jones, I'm just trying to decide where I want to put this so that we still have room. I'm going to write it down here. Mrs. Jones gave Gary, because remember that's what we're solving, how much did she give Gary? I always check to make sure I'm answering the question that they asked. Gave Gary 5/8 pizza. I'm going to say of the pizza, I think. Well, they're just saying pizza, so I'm going to go with the way they word it. Pizza. Okay, so for those of you who were getting confused with this, what I want to remind you of is that I could have actually drawn this in a different way. I could have said, all right, well, she has 1. So first let me model this 1 whole. So this is 1. And then she had another 4/8. So let me turn this into eighths to work with. So now I have 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8. And then she had another 4/8. So this is 4/8. And I'm going to go ahead and write that right here for us. We didn't have to do that. We had to show what was 1. But, ooh, that's a little blurry. Let me slide it over so you can see what I'm working on. There we go. So this is what she started out with. And then what did she have left in the end? In the end, she had 1, 2, 3, 4, 5, 6, 7. This is what she had left in the end. So this is what she gave to Gary. So this would be another way of modeling it, another way of drawing it. Of course, when you get into enormous fractions and really big numbers, you don't want to be writing out like 174/8. You don't want to be drawing that. But for the purposes of this right now, it's okay for us to model it this way to make us really understand it. So again, here we have 1, 2, 3, 4, 5, 6, 7, and you can see that Gary has 1, 2, 3, 4, 5, which matches up with what we have here. So this would have been another way of modeling it. You could have used a number line. There's a lot of different ways. But I do want you to get comfortable with doing it this way, where you show your 2 parts and your whole. Okay, so let's take a look at the next one. 2 left to go. And then you guys will be on your own. So here we go. Let me move it up a little, even though it's blurrier then. A baker had 2 pans of cornbread. He served 1 1/4 pans. What fraction of a pan was left? So I want you all to think about how would you model this? What are you going to do? So I'm going to start off by doing a similar diagram to what we have been doing. So let me show my parts and my whole. So he had 2 pans of cornbread. This is what he served, so this is part of it. And then we're looking for the fraction that was left. So what I know is I know what the whole thing is. So I'm going to mark that off as being 2 pans. And then the other thing that I do know is I know what he served. He served 1 1/4 pans. And I'm going to go ahead and mark that as what he served. Now it says what was left. So that's my question mark, and this is what's left. So right away what I can see is that I can just go ahead and do my subtraction. I can say that he started with 2 pans, and then what I can show is that he served 1 1/4 of those. And I want to figure out what does he have left. Now, for this one, what you're going to want to do is you're definitely going to want to you need to decompose your 2 into at least, all right, let me start again. You have a couple of different choices, and you're going to do whatever you're the most comfortable with. I'm going to do it 2 ways. I'm going to do it the shorter way, but it might be confusing for some of you. Then I'm going to do it in a slightly longer way that might make a lot more sense. So, the first way that I'm going to do it is I'm going to take this 2 and I'm going to decompose it into 1 4/4. And the reason I did that is that I can then deal with this 1 with this one, and I can deal with this 4th with these 4/4. So that's just like my way that makes a lot of sense for me. So that's why I decompose the 2 in 1 4/4, because 4/4 is just 1. So really what I have is 1 and 1, or 2. So now what I can show is that I have 1 4/4 minus 1 1/4. So this 1 minus that 1 leaves me 0 wholes. I have no wholes left. And then I have 4/4 minus 1/4. And so what do we have when we do 4/4 minus 1/4? I have 3/4. Let me just show you this part of it in a slightly different way over here. I'm going to do it up here. So I have 1 4/4, and I'm subtracting 1 1/4. So what you can see here is that I have 4/4 minus 1/4 is 3/4, and 1 minus 1, they cancel each other out. They're just gone. 1 minus 1 is 0. So I just ended up with 3/4. So I think that might be an easier way to look at it instead of doing it horizontally for some of you. So let's go back over here. Now another way that I could have done this is I could have actually turned this 2 into all fourths. So then this one would have also been 4/4. So I would have had 4/4 and 4/4. And if I'd done that, then I would have had a total of 8/4. So 2 is really 8/4. 4/4 from this one, 4/4 from this one. 1 and 1 is 2, but they also are 8/4. And then I could have done the same thing with this. I could have said that that 1 is 4/4, and that is just 1/4. And I could have combined those to make 5/4. And then I would have seen that 8/4 minus 5/4 is 3/4. So again, I could have just turned both of these completely into fourths instead of leaving them as mixed numbers. It's really just how you see it. You also, one more way, or one more thing you could have done, is you could have done a different diagram. And you could have initially modeled out 2 wholes, and you could have cut them into fourths. So again, I have to show that these 4 makes 1. So I'd have 1, 2, 3, 4, and then another 4th. So that represents, what was served. I'm running out of room here. And this is what was left. So you can see 1, 2, 3, 4, and 5. So that's 1 whole plus 1/4 was served. And that's what's left. So that's another way that you could have done it. Or you even could have just crossed off that 1 and then crossed off that 4th. Lots of different ways. Whichever way you choose to do it, what you're going to get is that 3/4 of a pan was left. So let's write that. Okay, we have one more problem to do. So, Marius combined 4/8 gallon of lemonade, 3/8 gallon of cranberry juice, and 6/8 gallon of soda water to make punch for a party. How many gallons of punch did he make in all? So let's try and imagine this. Let's try and think about what he's doing. So he has this lemonade, he has cranberry juice, and he has soda water, and he's using it all to make punch for a party. And here it tells us he's combining these. If he's combining them, it's like he's pouring them all into one giant container. So what we have here is we know the 3 parts. We're looking for the whole, and we also know that because we're looking for how much he made in all. So let's go ahead and do our diagram. And if I do this diagram, I'm going to show first that this is 4/8 of a gallon right here. So this is 4/8. Then I need this one, which is 3/8. And then over here he has 6/8. And I know that these are not drawn to scale, which means they're not really representing the true amounts. They're just showing that these are all parts. And then what we're looking for is this. We don't know what the entire thing is. So remember, when we have all the parts and we're looking for the whole, what we can do is we can add. So what we're going to do is we are going to add 4/8 plus 3/8 plus 6/8. Now remember, what we have learned here is that you can do this in lots of different ways. If you want, you can add these 2 together and then add that one. You can add these 2 together and add that one. You can add these 2 together and add that one. It doesn't matter. For me, it's just as easy to say 4 plus 3 is 7, and 7 and 6 is going to give me 13. And what size are each of these pieces? They're 8ths. So I'm going to have 4 plus 3 is 7 plus 6 is 13. I have 13/8 gallons. But we've also learned that we do not want to leave this as a mixed number. So we are going to want to we don't want to leave this as a fraction greater than 1. We want to turn this into a mixed number. So what I have to do is I have to figure out how many wholes are in this. It's definitely a fraction greater than 1. My numerator is greater than my denominator, so I have to pull my whole numbers out of that. So what I want to do is I want to look for 8ths. Since this is an 8th, let me see how many 8ths I can pull out of it. Well, I want to pull out 8/8 to make 1 whole. So this is going to be equal to 1 whole, 8/8. And if I take 13 pieces, if I have 13 pieces and I put 8 of them over there, that means that I have 5 to place over here, because 13 minus 8 is 5. And the size of those pieces is still 8ths. So this 8/8 is just 1, and this is 5/8. So another way of showing 13/8 is to say it's 1 and 5/8. So what I'm going to write over here is that Marius made 1 and 5/8. Remember, everything is gallons of punch. All right, so class, that is it. Remember that you are going to be doing word problems with fractions. I would like to see diagrams in your work, but you have the freedom to do this the way that works best for you. I do want you to be moving in the direction of doing diagrams similar to what we were doing here, where you're showing your parts and your whole, because that's really where you want to be moving towards, because doing this type of a diagram, when you get to really, really large numbers, is going to be a problem, or large fractions. So let's work on these, and you are going to be doing the problems from the homework set, not from the problem set, because we already did all the problem set problems. So, all right, I hope that you guys have a wonderful evening, and I will see you tomorrow morning in our Google Classroom. Have a great night.